Hello all. How are you all? You all hear me?
Yes,
Good
yes.
evening, sir.
Okay. You can hear me well? Great. Good evening. Just let me share my screen. This question we did yesterday. Yes, yeah. Have you all tried these two questions? Yes or no?
Yes, sir.
Sorry?
I did the question, so once can you show the answer for the second one?
Second one answer is -5.
I got the same, sir.
Good. Super. What about others? Bhanuri, Rituraj, Samhita? That is slow. Okay, let's see this one. A gun of mass m fires a bullet of mass small m. The speed ordered speed v. The gun is fitted with the concave mirror. A focal length f facing towards the bullet. Facing towards the bullet. Find the speed of separation of bullet and image just after gun was fired. Just after gun was fired. This way to combine momentum also. M1 V1 equals to linear momentum formula. Consumption of linear momentum. Will you try this? Go and try this. you want to hint, want to get a hint, see here. Conservation of momentum we have done here. Initial equals to final. So what do you think? Any idea? Okay, let's see. A mirror. So obviously, yeah, you can see the diagram. It's already drawn. Bullet is in opposite direction, facing towards it. You're facing towards it. Towards it. So this is the distance from the mirror. Object distance. So object distance we have taken as x. So obviously object distance always minus. Focus is obviously minus here because left side of the mirror. So this is your V you will get. V equals to fx, f minus x. Okay. Now this is what a V. V is here distance or image distance. So if we differentiate with respect to t, we'll get velocity. So yes, it is u by v form. So we have to do u by v form. Differentiation u by v form. Aditi, have I taught this a differentiation integration? I guess, right? I taught you guys.
So I don't have the book right now.
It's okay, but
Outside. I
we have
don't.
done, right?
I guess I need to just check the book. I guess I don't remember.
Okay, let me check. It's not opening. Yes, we have done that. Okay. So even though differentiation, I'll give you some idea. dv by dt means v is your distance. In short, dx by dt. Differentiation of x, u by v form. U and v both are functions, so u will keep constant. Will differentiate v minus v will keep constant. Will differentiate u divided by v square. This is the formula. So here u is fx. Okay, this is the formula. So dx by dt. F is your constant only. So we just differentiated this one. D, F here remove this one. The V is common here. Then differentiation of dx by dt minus dx by dt minus 1 fx. So yeah, sorry. Yeah. In this one, f and f will become f square, fx and fx will get cancelled, and dx by dt we are taking it common. Dx by dt we are taking it common outside, and f minus x the whole square is same as it is. Now at initial point t is 0, x is 0. Yeah, in this case, when it is time is 0, initial condition, the speed of the suppression of bullet, and image just after gun was fired, initial case, we need to find out. So dx by dt is similar to dv by dt, du by dt. So from here, we got it, m plus m into v by m. M plus m into v by m. So final minus initial. So dx by dt minus of minus dx by dt from this one. It will become 2 dx by dt, that is 2m plus m by m into v. Small m is mass of this bullet and capital M is mass of gun. You will get same value. Actually, v and u will be same here. This is v and it should be same. This value should be same. Not to do this again. So this will be your final answer. 2 times of this distance. So u is opposite of v, which is 2 times of mass into velocity speed.
So could you explain the above part once?
The differentiation part.
No, I got that separate. From du is equal to dx.
Okay. So this is excuse me. So this is what we found here. This is a u value here. This part is u value. U equals to m small m plus capital M divided by m into v. That is what we are using here, which is equals to, like, if we differentiate du by dt, which is equals to dx by dt. It's like a velocity. Du is u is what? Distance of object. So same we are making it here. Distance of x is your distance of object here. So distance by time is your velocity. So yes, we are taking it as a velocity here. dx by dt, that is velocity into mass of sum of mass and divided by mass of gun. then we are subtracting dv by dt minus du by dt, final minus initial. In short, we have both values same in the initial case. Both values here same. So it will become twice of it, double of it, double of dx by dt. From here also we got here negative. Because u is negative here. That's why we wrote here negative. So minus of dx by dt. Even we should mention here also negative. Here also we should mention negative.
So V is twice of U.
Not v. See, this is difference. This, sum of, we can say, this is v minus u. So dv by dt minus du by dt. U is your, this is your velocity final. This is your initial velocity. Change of velocity. So dx by dt minus dx by dt, that will become 2 dx by dt. So dx by dt we already got it, that is m plus m, and that so on. This mixed velocity dv by dt. V here, this v is not velocity dv by dt. This is your image distance. U is object
Object
distance.
distance.
So don't get mixed up with this. I should have used some different values, or sorry, variables. But okay.
Yes, that was my doubt. The V looked like a U, so I got confused.
Yeah. I got it. I understood that. Because this v is image distance, and dv by dt is your image distance velocity. You can say final velocity. Or I should have used some different variables instead of this v and u. ठीक है. Understood? Is it clear now?
Yes, sir.
Others?
Yes, sir.
Shall we move next, or you are writing? Is anyone writing?
So just can you show the last part? I need to copy that.
That is similar one. U and v, u is equals to v, so it's same way. We're just getting same way here. Actually, this one can be easy a direct one, right? Instead of doing all this differentiation, opposite v and u will be same. So m plus m by m into v minus of minus m plus m by m into v. It is twice of those. Obviously, this is direct easy way. That thing, this value we already got from the first, from here only. No need to differentiate also. ठीक है, shall we go next? चलो नेक्स्ट करेंगे. This was till now till now whatever we studied is like a basic introduction of it, we can say. Like last two classes we just had introduction. Now we'll see actually in this one ray optics, like how the rays are entering and what is happening there. Snell's law you already know. You won't derive, but yeah, we'll see that how it is formed. Some theorems, how it transmit, and some formulas, some difficult formulas, typical formulas, critical angle. Where are these things? No, where is that? 1 second. This is most important. Instruments. Simple, compound, astronomical. Mostly they're asking, see, these are questions, PMT and mains. Mostly they will ask that type of questions only. Yeah. Okay, we'll see some typical questions also. Let's come back to our topic. So don't think that chapter is over. No, we just started. So you have to relax and study. Okay, reflection of light that you already know. Bouncing back of light into the same medium. So no need to write this again. You already wrote that. So write those points which you haven't written. Okay, so like whenever ray entering from rarer to denser medium, it bends towards the normal. So remember that we will always measure from everything from the normal. These rays bend, it should go this way, but it should bend, it will bend towards the normal as it is changing from rarer to denser. Towards the normal in the sense this side, from this range. This is actual path. Actual path should be moving this way, but refracted path. It has bent towards the normal. This ray has moved towards the normal. And same way opposite. Moving from denser to rarer medium. It should go this way, but it will move away from the normal. it can be this much distance or more distance. Means it's this ray, it should move here, but it's moving away side, not towards side, not this side. This is called towards. This is called away from the normal. Guys, are you understanding words? This is towards normal. This direction is called towards the normal. And this direction is called away from the normal. Keep in mind, okay? Words makes difference. Towards and away. You got the difference towards and away? Everyone?
Yes, sir.
Okay. Others? Is it pretty?
Yes, sir.
Yeah. It's clear, right? Okay. If you're not clear, you ask me straight away. Don't worry. Chalo, okay. Next. This laws, incident ray, normal ray, reflected ray lies in a same plane. Snell's law also, sine of angle of incident to sine of angle of refraction. Or ratio of sine I by sine R. This you already know. V1 by V2. mu2 by mu1. If you remember, this is the way we got this formula. C by V2, C by V1. C is your velocity of light in vacuum. And V1 is the first medium, V2 is the second medium. V1, V2. So C by V is your absolute refractive index. Here, it's mentioned here also. So the absolute refractive index of first medium and absolute refractive index of in second medium. So that means first medium we are relating with speed of light in vacuum. Second medium also we are relating with speed of light in vacuum. In short, both we are comparing with vacuum so that we can cancel vacuum values and we can get remaining value, remaining ratio. I mean. If you remember, well and good. If you don't, then make a note of it. This all things are same only. It's not a big deal here. Is anyone writing? Shall I move? So move to next. Okay. So this is Cauchy's formula. Refractive index equals to A plus B by lambda squared, C by lambda to the power 4. Now, lambda is the wavelength. So that is obvious. Wavelength of red is greater than wavelength of violet. This formula will not use much. Rarely we will use. As wavelength is more, the refractive index will be opposite. Because of this speed we got here. So we can remember like that. Higher the wavelength, lesser the refractive index.
So V is inversely proportional to mu.
Yeah.
Sir, I have a doubt.
Bolo.
Sir, why you write a nu1 by nu2 and n1 by n2 is equal to
Yeah.
sin I by sin p. Why is it not the reverse?
Sin I by sin R, yeah.
Yes, sir. Like, I don't understand why do you write it like that? Like, I also got confused in class. Like, they wrote opposite for sin I by psi r, but they wrote n2 by n1. Why is it like that?
See, this N2 by N1 means what? Refractive index of 1 with respect to 2. See, here we wrote, where is it? Yes. Mu1 is the first medium with respect to vacuum. We are comparing with this refractive index with absolute, in short, absolute refractive index. So mu1 is first medium with respect to vacuum. Mu2 is the second medium with respect to vacuum. So refractive index of second medium with respect to first one. That is what mu1 and mu2 means. The refractive index of second one with respect to first. So we are going from second to first in short. If I draw here, this is first medium, second medium. We are going like this. Sorry, not first to second, first to second to first, this is first to second. If we are finding for this medium because it is traveling from here. So we are saying refractive index of 2 with respect to 1. So in that, sign of angle of incident. This is angle of incident sin I to the angle of reflection. So it is your sin reflection. Reflection is happening inside the medium too. Formula wise, we are getting like this. We wrote here. Formula wise, we are getting N2 by N1 because it is N12. It's going to 2 from 1. So it is N2 by N1.
So it's refractive index with respect to glass to air.
Yeah, whatever medium it is, glass, air, or air to what. So don't remember just glass and air. Just understand where it is going. So wherever it is going towards the 2, that means 2 with respect to 1. From 1 it is coming.
Okay, so n by 2 means it's coming from first medium to second medium
Yeah,
and the reverse.
yes. It's going from 1 to 2. In short, we are finding for 2. We're not finding for 1.
Okay, so that's how you write n2 by n1.
Exactly.
Okay.
So here incident is from the 1. So it doesn't matter where it is. So sign of incident and sign of reflection. ठीक है?
Yes, sir.
चलो. Like this, you keep asking doubts, then only you can score very good marks. Then we'll get clear your doubts. Okay. This one, I guess you remember the refractive index of mediums, ratio of those mediums how many mediums are there? Let it be 1, 2, 3. If you multiply all, it will be 1 only. That is a common thing, you know. Yeah, this is important. The refractive index depends on nature of medium, wavelength, and temperature of medium. Obviously, temperature depends. Because yeah, obviously, if we increase the temperature of any liquid or any fluid or anything, its density changes. With increase with increase in temperature, mu decreases, refractive index decreases. Is this 3 point clear? You can remember, right?
Yes, sir.
Nature of medium, wavelength, temperature. Increase in temperature, mu decreases. Okay. Okay, then we can continue transmission of light tomorrow. Now we have math class. If you're done writing, we can stop.
Done, sir.
Okay. Others?
Done, sir.
ठीक. Chalo. Bye everyone.
Thank you, sir.
And join early as possible.